Welcome, grade 7. This is the second part of the practice assessment, and it's on the performance expectation MSESS 24. So you will be doing some modeling for this one. Remember, in 3 weeks, those practice assessment grades that you got yesterday, last class, you got your first assessment grade. For this assessment, you will get a grade, but they will be replaced by the summative, which is on 2 performance expectations, okay? So what we want you to do for this one is develop a model. So you need a pencil and paper today to describe the cycling of matter through Earth systems driven by energy from the sun and the force of gravity, okay? So we touched on this standard while we were doing the super bloom phenomenon. So you can use your old notes if you want to help you through this assessment, but it definitely pertains to weather tracking as well. So put your name and period. Here it's asking you to open up your weather tracker and write in, this is quite easy, just write in the last day that you track the weather for one of your cities. Okay, whether it's Chicago, Illinois, LA, the last day, put the date, the city, only high temperature, and the rest of the weather variables here. Okay, so you're just writing it in. Then you're looking at the weather maps. Um, this is a map of America, and it shows you the different amounts of precipitation that they get in a year. Down here near Florida and Alabama, it's quite wet. And then we also have a little bit less wet, but still wet along the East Coast here. And then more into the middle parts of America, you have a little less wet, but you still get some wet area in here. Over here, kind of in the mountainous areas, we have more of a dry um, part of the country. And then until we get to the West Coast, and then it's super wet here in Seattle and Portland areas. Um, and even down into California, we get some quite not very wet, but definitely wet conditions. Okay, if you have a city in Mexico, click on this link, and it'll show you the precipitation. Similar map, but for Mexico here. Okay, so you're going to need that map. Here are the air masses map. It shows you which part of the states is influenced by certain air masses. Okay, and then what we want you to do for this is they want you to predict the weather for your city. Use the maps and past data to help your predictions. So what we want you to do is we want you to predict the weather using these maps here. Okay, um, and make sure you know your air masses because that will help you predict things like temperature, humidity. Okay, but we also want you to use this wetness to predict precipitation levels. Okay, for example, if you have a city in this dry area, you might have little or no precipitation. If you have a city kind of on the east coast or west coast, you might want to add a lot of precipitation compared to your past day's precipitation. Okay, so we want to use these maps to kind of decide on our precipitation level. Okay, down here, this is the third part where you're going to have to model, and this part you have to showcase in Flipgrid, and you have the whole class to do this. Create a model of the water cycle that would fit the predicted weather variables for your city. Explain your model in a Flipgrid video, only showing the model. Don't show your face in the video, just show your model. And there's a feature where you can actually take a picture of it and then it uploads it to Flipgrid. If not, you can just hold it up. Be sure to explain why some components of the water cycle were not included or highlighted in your model. For example, you may not predict it to rain in your city because it's in a dry area. So you wouldn't model precipitation. Okay? Try and model the following components. There's 1, 2, 3, 4, 5, 6, 7, 8. Now, it might be hard to model pressure trend, but you might try your best to model pressure. Like what is happening to the air in a low pressure? What is happening to the air in a high pressure? Okay. Sky conditions you can model, precipitation you can model, wind direction. How would you model wind? How would you model wind speed? Maybe through labels and swirls or lines that swirl around to show wind. Humidity, what is humidity? The amount of water vapor in the air. How would you model that? How would you model temperature? Things that we've already done in the super bloom phenomenon. So we'd like you to try to model these things into your on your paper, okay, for your city. If your city is by an ocean, you could model the city close to the ocean. So again, this is practice. We want you to get into the habit of trying to model these weather components. When you click on your class, period 3 is first and then 4, make sure to click on the right class because that's how I'm grading it. This will pop up. And this will show you the little rubric for your model. It will also link you to the actual assessment, and it will link you to Haiku Learning to submit your assessment. Okay, so we will definitely want you to do your Flipgrid, but we also want you to submit this in Haiku. So you have to submit 2 parts. Okay, here's the rubric. The student can use a clear voice to explain the model. The student has good model components like a zoom in bubble, arrows, explanations, labels, colors, and pictures. If you're running out of time, don't add color. If you have some time, add color. Okay? The student has at least 4 weather variables modeled. If you don't have at least 4 weather variables modeled, you're not going to get a meeting for your model. So make sure that you at least have 4. Okay? Record your response. You have 1.5 minutes, so make sure your model is done before you record and you've rehearsed what you're going to say. You have the whole class to watch this video, to fill out the doc, do the model, and record the response. Okay? If you get it done in class time, I'm going to try my best to get this grade into your progress report for this Friday. Okay? Good luck, and you'll be in your own breakout room to do this. Thanks.